how's everyone doing? Hope you're doing well. If you've seen the title, the ms880 kit saw from Farmertec, Forma, whatever they go by. I'm going to do this a little different. I thought about videoing the whole assembly. I probably will show bits and pieces of it, but it's looking just like it's just, you know, about like any other basic Stihl pro level saw. The only difference being these cases I've used 8 bolts as to where most of the others use 5 or 6 depending on what saw you're building. 4 in the oil tank area and 4 in the crankcase area itself, and it does still use the big bolts, but they're a lot longer, like say a 660 would use, or a later model 066. Everything went together flawless. Feel the crank and everything feels good, lined right up perfect. Piston's got some sharp edges on it we'll probably have to knock down, but we'll get to that in a later part of this video. But I guess what this is going to kind of be is just my approach to porting a saw. I've done it several times, but you know, why not make another one on this big one, and you'll see what I've done and how it performs in the end. I'm not the world's best at this. I have had a grinder in my hands and have been porting things since the late 90s. Done everything from old Mopar cylinder heads to small block Ford LS1 stuff. Not the world's best in the world at it, but not the world's worst either. My saws run good enough to suit me. You know, I may build you one and you not even like how it runs, but I kind of watch how many saws I build for other people anyway. Most of the ones I've sent out, the people were satisfied with, so you know, I'm not going to BS you, I guess is what I'm saying, and what I show you here, it's just how I go about doing it on most chainsaws. Very first thing you're going to want to do is find out whether or not you're going to need to run a base gasket, or whether you want to run a base gasket. And whichever route you choose or have to do, a lot of the last few saws I've done, as you've seen, we've had to put a base gasket on due to aftermarket and OEM cylinders. It just, you know, it is what it is, unless you've got a precision lathe in your shop to where you can cut the base of the cylinders and make you some mandrels to go in and cut the squish band out. You know, most of us are left to just, you know, minimal block sanding to the bottom of the deck of the cylinder. And some people will probably even frown on that, but I've been doing it for years and really never had a problem, you know, as long as you take your time and don't go too crazy with it. But with that said, most of you are going to know how to check your squish. You'll take you some solder, go in your spark plug hole, and I do recommend you check it on each corner. You know, some can vary. You can have tighter spots in that squish band, especially on the aftermarket stuff, as sloppy as they get with plating. You know, most stock saws are going to be anywhere from 40 to 60 thousandths, so if you've got squish down around 30 thousandths, or, you know, anything between 18 and 30 thousandths is going to be safe and going to perform better than it did stock and make more compression than stock. And again, this is just my take on it. This saw, we went ahead and verified our squish. I did do enough of block sanding to the base of this just to make sure that it was flat and true. We're not running a base gasket. We've got right at 28 thousandths squish. That's like an average around each corner. Some places it's a little looser, some places it's a little tighter, but 28 thou is a good solid round number to go with. Then you're going to want to get yourself a degree wheel. I've honestly, in the past, I've only had this, I don't know, a little over a year, maybe 2 years. I just really don't remember, but these wheels are all over eBay. I think it was less than 20 bucks, and then you can pick yourself up a 1/2 inch chuck for a drill press. Again, less than 20 bucks. I think it actually used a 1/2 inch bolt that went in the end and a nut on it, and you know, it's a done deal once you get everything cinched and locked down. it's just there until you get your saw done. As far as setting up the degree wheel, there's some really good videos out there. I'm not going to shout out any names or anything, but if you want to make sure the person is using a piston stop and showing you how to properly balance that wheel, if they're not doing that and not doing a complete zero balance of the wheel, just find yourself another video to watch. But I always use a piston stop, and I always make sure my wheel is as balanced as I can possibly get it. None of this is rocket science anyway. It's just, you know, it is what it is. Checking the port timing. You can either, on your exhaust port, a lot of people use the ray of light method. That's fine. I find out I get, you know, basically the same using the ray of light method or eyeballing it as I would using a, you know, a piece of stiff welding wire or a piece of solder or something. And airflow under compression starts around 50 thousandths, you know, give or take. Most automotive camshaft manufacturers, such as like crane cams or comp cams, most of the time, if you see duration measured on that camshaft, it's measured at 50 thousandths lift, and it is for that reason, because airflow just doesn't start moving efficiently to 50 thousandths. But with that said, a lot of the times you'll see me use a piece of welding wire, a piece of solder. Usually it's welding wire on the transfers because they're so hard to get into, but I've checked it on this saw both ways with the stiff wire and with the ray of light, and then eyeballing the intake port, and I'm coming up with the same numbers either way, which are very, very favorable to port work. If you see a lot of guys doing crazy machine work, it's a lot of the times it's to correct poor timing numbers from the get-go. Like my Farmertec 660, port timing on it was just, in my opinion, I didn't really like it. It was, the exhaust port was opening way too early on it, but you know, again, I didn't have a lathe here. I didn't have a way to make a pop-up piston or cut the squish band or any of that, so we just went with it, and at the end of the day it made a pretty good dang strong milling saw. So with that said, exhaust opening on this is dead on 105 degrees, and you know, I checked it every way because those numbers were so good. Gives us a long way to work with. We will alter that, but it's not going to be a whole lot because I want to retain as much torque and compression as I can in this build. Transfers are opening kind of late, in my opinion. They're opening dead on 130 degrees. We will try to move those as far as we can safely move them. What I'll do is put a ring in and push it up to that desired timing number that I want, and make a mark and cut to that mark, and then put the cylinder back on, retime again. Probably do that on the exhaust as well, but I don't really plan on moving it that far, so I don't know if it's going to be necessary or not. Intake, like I said, I've checked it by eyeballing it, checked it, you know, measuring it by thousandths as well, and it's opening dead on 70 degrees. Again, pretty good number to work with. It's not nowhere near as early as some of the last aftermarket cylinders I've had a hold of, but you know, we can work with that. I've not chose any specific numbers on this, but I'd kind of want duration to be between 150 and 155 degrees on each of those ports. This saw has a very large intake port. It's super wide. It has huge transfers. It has a huge carburetor, one of the biggest I've looked at, to go on it. So, you know, there's not going to be a need for a whole lot of intake duration. So, we'll grind on that port and try to get it to where we want it. But if it's going to end up making like a big, huge port that's going to lose a lot of velocity, you know, I'll just quit, and the numbers will just be what it is, you know. But I'm hoping we can at least squeak 150 degrees of duration out of it without having to notch the piston, which I've done in the past. You know, I don't really want to do it on this because there's not enough room on the exhaust side to notch the piston any at all over there. It probably has maybe 30 thousandths before it would be free porting, so you know we're not going to take any material off the bottom of the piston on the exhaust side. What else? Yeah, that's the next thing we're going to do is I'm going to pull this cylinder off and show you. There's a place in the exhaust port kind of where the plating has spilled over and ran over into the port. So what I'm going to do first is clean that up. It's not on the very edge of the port to where it would affect the exhaust timing much at all, but what we're going to do is I'll clean that up and blend it in, and then we'll put the cylinder back on and recheck the timing on that cylinder. So I guess what this is going to kind of be is just, you know, like I said, another video on my take on cylinder porting. It'll probably be a long one. Some of you, it seems like some of the longer videos are doing pretty good on porting, so you know, we'll make another one and try to make it a little better than the last. I've done some that I broke up into series, and I've watched other people's series, and it's just aggravating having to sit and wait on that next video to show up. And I've got really fast internet here, so why not take advantage of it and just edit and upload another long video. Okay guys, I'm going to show you on this exhaust port exactly what I was referring to. You should be able to see that. It kind of bubbles up, and honestly it kind of looks like a bead of weld across the entrance of the exhaust port, but it's not all the way over to the edge, which is kind of weird, which was, you know, how I was able to determine the exhaust port timing. But I'm willing to bet once I get that cut out and blend it in that my exhaust timing's gonna fall pretty dang close to where I want it to be anyway. But you know, we'll just have to see. I'll give you a look at the rest of it. The plating on this one's actually really good. The squish band's not anywhere near as sloppy as some other ones I've seen. Transfer ports are a little rough. It's not a big deal. They'll clean up and smooth out. There's, on one of them, there's just a little bit of plate and overhang. We'll take care of that, and they're kind of close to being blended into the base anyway, but we'll go ahead and work it in. I'm not going to go crazy with it, but you know, I would like to get them a little opened up and a little smoother so we'll have better throttle response and a little better torque in the cut. But this intake port's kind of dang big. It could be widened a little bit, but I'm not going to mess with it a lot. I'm pretty bad in the past for kind of butchering intake ports. It's just one of the ports I have the hardest time out of, but here lately I've just been trying to stay kind of conservative with them and just make sure I get a good high flowing port at the end of the day. I really like the design of this for an aftermarket cylinder. It's one of the best I've looked at in a while, so I'm hoping that we can make a really strong saw out of this. And hopefully the next thing you guys see, I'm going to try to get a GoPro set up, is to where we can cut on the exhaust port a little. I'm not going to do every bit of that, but I'll show you enough just to give you a general idea of what I've done to this cylinder in the end. These cutters are very aggressive. These are not your cheap cutters you see on eBay. again, I'm just trying to cut that spill over from the plating process down. And you're going to get chatter when you get up next to a corner. It just is what it is. And whatever tooling you have, I highly recommend you get a pedal. Okay, you guys, I'm going to do something here next that some people are going to frown on, but what I'm going to do is go ahead and just take a few swipes out of the floor of the intake, just mainly for curiosity to see how far it moves it, because this thing it does have a really long stroke. I'm wanting to say it was like 41 millimeters, maybe more. I'll have to go back and look, but it's really long, and you know, it's going to take a lot to move it, say 5 degrees. So what I'm going to do is just take a few swipes, you know, not get crazy and make a mess, but that way when we go back together, just to see what it done as far as the intake timing. So I'm going to start, I'm going to take a couple swipes off of this intake and clean it up. Not much, because I don't need to move it about, you know, I need to move it about as much as I did the first time. When I'm running this slow, I'm running it somewhere in this area. But, you know, it'll go a lot further, but this cutter is really aggressive, really sharp, and takes a lot of dang material. And the motor on this setup has the same amount of torque at any speed. And hopefully it moved it the other 2 or 3 degrees that we needed to hit our desired timing number. Okay guys, so we've got, let's see if I can angle it. There you can see it. The line, it's all but gone on both sides, and that was going to set the transfers around 123 degrees opening. I'm shooting for like 102.5, 103 on the exhaust opening. I think that's about right where it's going to end up once I do the blending in and the polish work. And once we get to the bottom of the line on this, you know, it's going to be in that somewhere around 20, 21 degrees of blowdown area. And that, like I said, that's kind of where I'm shooting for. So, yeah, what I'm going to do now is start doing some fine cleanup work on the whole cylinder, and then we'll get it back on. I've got about another hour here I can play around with this. And it's already getting a little late, but I think we can get this thing most of the way knocked out here tonight. Okay, so I've changed the bit on the right angle handpiece. This thing's diamond cut. It's a lot finer. This is mainly just to clean them up. I really wish I could get a hold of a a way to do a cartridge roll here, but that's just not going to happen. As you can see, we've kind of stuck to the same angle on this as it had to begin with. It may be angled toward the top just a little bit, and pulled back toward the intake, but it's not anything drastic. We can run this at a little higher RPM because it is a really fine cut. That's what I'm doing now, is kind of trying to pull that angle back toward the intake and clean up any imperfections that we may have got in it from the rougher bit. Which honestly, those double cuts are just not a very rough bit at all. And I know, okay, this is something I don't really like going over much, but is deburring, or chamfering, some people call it, which is basically you're just knocking down the edge around that port that you just reshaped. Some people go overboard, lose a lot of sleep about it, but there's several ways you can do it. You can go around those ports with the diamond ball. My hands are way too shaky to do that. I've done it in the past, but usually end up making a bigger mess than I started with. But I prefer the sanding method. But the first thing I'll do is I'll take a sandpaper roll, cartridge roll, whatever you want to call it, and we'll work around the edge of that port. And then I'll take, like, say, 600 grit paper afterwards and go back around it and do each port by hand. It takes a little longer than it would, say, if you were just going around with a diamond ball, but you know, at the end of the day, it is something you need to spend a little bit of time on, but it's not the end-all nightmare that people think. You're basically just making sure the rings have a good entrance and exit transition, and that there's no burrs there to kind of wreck your new piston. And some people are totally going to disagree with this, but you know, I've yet to hang a ring. Knock on wood, this one will probably blow up. And I've not wrecked the piston yet, and I'm sure this one will do that. And if it does, you'll never know about it, because I'll just buy a new cylinder and redo it, and yeah. The proper way would be to put a diamond ball on that right angle and go in there, but like I said, my hands are way too shaky, and I'm basically doing the same damn thing here. You get the idea. I'll go over it with sandpaper at the very end, and then that'll be it. Yes, that is slightly enlarging that port. And you can do the whole port job with these things, but you're going to go through a whole heck of a lot of them if you try. I'm having to angle that around where I can see what in the world I'm doing. That is a pretty aggressive cartridge roll. I think it's 220 grit or so. As you can see, it's already doing a really nice job at opening this up and just mainly knocking down that rough edge. Your intake boot does cover a lot of this. You can take it really far. I am going to take it a little further than this, but obviously due to this little port, whatever in the world that it is for, I'm not going to be able to cut real far or I'll end up with a trench inside of my port, and we definitely don't want that. So I'm going to work this just a little bit more and then clean everything up in here and just call it is what it is. It'll be a nice high flowing port at the end when we're done. And I try to do this on most of my intake ports because, I don't know, I do feel that it does aid in velocity. Alright guys, so I went around that piston just with an old wore out cartridge roll just to knock down some of the sharp edges on it. There wasn't very many, but she's all good now. I did knock a little bit more off the deck of this. that may or may not tighten Squish up a thousandths or so. I won't know till I bolt it on. I'm hoping I knocked enough off of it to make up for, you know, what little glue we're going to put on it. And if you're picking up 3 or 4 thousandths from glue, you're really using too much. But again, to each their own. Anyway, exhaust port turned out really nice. You guys watched me lay the polish on it. Give you a look from the inside. If you remember, we had the big lip in there originally just from the overspill from the casting process. I will say I did go back over the transfer ports again. There was just some places I didn't like over in the corners of them, but we've got that all good and uniform now, and a good smooth finish on everything. Give you a look at the other side, and you know, you need to try to make those look as identical as you can. You know, if you can't get it perfect, it's not that big of a deal either, but intake port, you guys watch me do that. I did have to work that upper lip with some sandpaper quite a bit. It was sharp as a razor. You know, that may or may not cause a problem. A lot of OEM cylinders I've pulled down would about cut you on any port of them, but I just don't like taking risks. As you can see, we got a really nice finish in there as well. Just some nice high flowing ports, and you know, that's the whole process of porting a cylinder. So the next thing you guys should see, I'm going to glue this on and then pull all my final numbers and Squish, and then I'll let you know where we're at and kind of why I chose to go that route. Alright guys, gonna kind of wrap this little part up. Got the cylinder on, glued down. My very largest ring compressor in my set, I was barely able to make it work, but the bottom of that cylinder was tapered, so it did kind of make the rings go in easier. We've got our Moto seal on. I like either using it or Durco, but Durco's a little hard to get around here. Usually you have to order it and it takes forever to get here, but you know, it is what it is. The Moto seal seems to work really good. Final timing numbers on this. Again, did not want to make a screamer out of this, but exhaust, we got an opening of 103 degrees. That gives us 154 degrees of duration on that port. That's plenty. That port's super huge. We got a real nice finish on it. It should have a really nice pop to it and have a lot of torque in the cut and be able to rev out as near as high as we want it to. Transfers, we moved those. They're open at 124 degrees. I was kind of shooting for that 123, but you know, it is what it is. Once I got it on and checked it, you know, I was perfectly fine by missing that 1 degree. You know, it's not going to make or break the build. That gives us 21 degrees of blowdown. That's just fine. That's plenty of transfer port duration for this. That lets us know that we'll have plenty of air and fuel charge in the combustion chamber, and that it's not going to go lean in a big long cut while we're milling. And a lot of people get confused with transfer port duration, but that's basically the gist of it. The lower your blowdown number is, the more transfer port duration you have, and the more air and fuel mix you're going to have in the combustion chamber to work with. Intake port 76 degrees, it's 152 degrees of duration. That's kind of what I was shooting for. Again, very large port, super wide already. It could be widened more, but just, you know, didn't really see the need in it. Saw as a very large carburetor, and at the end of the day, these numbers should work. You know, I believe it's going to be a really strong saw. Should have a lot of static compression. We ended up, after glue, dead on 27 thousandths Squish, where I'd actually block sanded another thou or so off of the base. So yeah, I'm pretty tickled with all the numbers. The next thing I'm going to try to do is get all the AV bushings in and get the handle mounted on it. This video is going to be super long anyway. I'm not even sure how or what I'm going to do with it, because I have a lot of footage of me porting the cylinder on the GoPro. Not sure what I'm going to do with that either, but you know, just bear with me. I'll do what I can and try to get you guys an upload on this, and I really hope everyone wasn't expecting a bolt for bolt on this, because I've just not had time to do it. It's been raining the last few days, and other stuff that was in my plans couldn't do, so we're here on the 880. But with that said, I'm going to shut you guys off, and if I run into anything that's weird or something somebody would need to know assembling one of these, I'll pull the camera back up and show you what I come up with. I'm gonna wrap this video up. It's probably way too long anyway. So I was making kind of like a whining sound. I have went back into it, and it is to do with the clutch oiler assembly. I oiled everything up and block sanded the bottom base of the clutch a little bit, and it quietened it down a lot, so I'm guessing it's just maybe there's a burr in there that will probably eventually clearance itself, but it was nothing bad, nothing that's going to hurt the saw. Everything still looked a-okay, and it's throwing out a ton of oil to the bar and chains, so I believe she'll be good to go. I wish I had something bigger to cut or harder, but I'm covered in poison vine right now. I have it all over me on my face. It's really unpleasant, and I'm kind of trying to stay out of the woods this weekend, but you never know. I'm a little crazy. I'm liable to end up back in the woods somewhere again, so who knows. If I decide to go do something, you know, we will take this saw, but then again, they're giving rain and thunderstorms all weekend anyway, so yeah, whenever I get this thing in something better to cut, you guys will be the first to see it, I guess, or maybe even shoved in the mill, I don't know, but saw's very large, very powerful, take a lot of getting used to. It's like heavier than, like, say, a Mac 250 or 300, or like the 170 that I have. It's heavier than those saws, and you know, a lot more powerful as well. But yeah, it was a fun project. You know, glad to share it with you guys. I know some of you like the longer videos. If you can put together any of the Stihl Pro level saws, you're not going to have an issue putting this together at all. The only other thing I did do, I went in and made a little opening in this side of the front of the muffler cover. It did seem to give it a little more throttle response, but it was pretty dang zippy anyway already. And as you can hear in the video, she'll run up and tag the limiter pretty quick. I don't know that I'll look into a limited coil. It seems like I've read, you know, maybe a 084, 088 coil will work. And I'd seen something else where somebody said ms361 coil will bolt on it. I don't know. And to my understanding, most of those are unlimited anyway. But I do know, like, your older coil on the older pro level saws is just not going to fit it. It just, the way it bolts on is totally different. So, you know, if we want to turn it on up, you know, we're going to have to look into a coil. But I think it'll be just fine the way it is. Yeah, thing's just a beast. You know, like I said, I'm happy to share it with you guys. Any questions, you're welcome to ask. Sorry I didn't do a bolt for bolt on it, but the video would have probably been 4 hours long. I don't know. It's just I've been piddling with it on and off for, you know, about a week when I got time, and, you know, done the first start last night and got her buttoned up today and able to make a cut with it, and seems all as well. All the parts were, you know, compared to what Farmertec used to be, most of the parts were top notch. Everything fit right. In the past I've had trouble with the handles bolting up. It seemed like it was a nightmare getting screws in them, but the last few I've done just kind of went right together. So you know, props to Farmertec. They're stepping up their game and getting some stuff out here to where us normal people can afford to get a big huge saw and not have $2,500 in it. But anyway, gonna quit running my mouth and shut this off. You guys stay safe and have a good one.